numbers are just simply numbers, and you use your same distributive property, and we're going to multiply here, and then we're going to multiply here, so we're just going to distribute this. But when you do, you have to use your rules of your radicals. So I have the root of 15 times 3, okay, plus 2, this 2 stays outside, times the root of only what goes inside underneath the roots gets multiplied. 5 times 15. Now, 15 over here is 5 times 3, and lo and behold, I have 2 3's. My index is 2, so I bring 1 out as 3, root 5. And over here, I have 5 times 5 times 3, 2 roots of 5. Now, I have to bring that 5 out. Well, where does it go? It gets multiplied by the 2. So it's 2 times, bring the 5 out, gives me the 10, 2 times 5, and I'm left with root 3 inside. So now my final answer is 3 root 5 plus 10 root 3. Okay, for this problem we're going to distribute this radical 2/3 over top of the radical 27/2 first. So basically we're going to use our distributive property and do this. Now when we do this, we're going to actually extract some roots at the same time. So I'm going to first show you what this is. This is, remember by your laws, I can have root 2 times 27. I can leave it all in here. 2 times 27 over 3 times 2. Now there's a reason why I'm leaving this like this. And that's because I want to cancel some things. At this point, I can cancel the 2 into the 2 and the 3 into the 27, and I just end up with root 9 on the numerator because root 1 on the denominator is going to be 1. Okay, so that's minus, okay, now multiplying by this fraction, I have 3 times root 2 over root 6. Now I separated this one, okay. I don't have to separate this one because I can actually take this one, and this is really root 2 times root 3. So if I hadn't done this together like root 6, root 2 times root 3, I can cancel out the root 2's in this one, and I just have 3 over root 3. So again, up here I have root 9 over 1 minus 3 over root 3. Well, root 9 is just 3, so I have 3 minus 3 over root 3. So what I'm going to do is multiply this one by root 3 over 3, and I get 3 minus 3 root 3 over 3, and now these two 3's can cancel out only, and I end up with 3 minus root 3. Okay, what I have to do to this problem is, notice you have the cubed roots. When your index is 3 or higher, you need that many factors of the same exact thing. I've said this before. So what I really need in here is 3 3's, not 1 3, to get rid of this denominator. But before I do that, what I'm going to do is I'm going to factor these out, and I'm going to take out what I can out of what's up there. Okay? So, and then I'll know what I've got left to work with. So I have the cubed root of 2 times 3 times 3 in this one, and I have plus 3 times the cubed root of 54. Well, 54 is 27 times 2. So really, 27 times, well, you can't see that, can you? 27 times 2, the cubed root of that, if I have a 3 out here, this one is 3 cubed, and I have 3 factors of 3 so it can come out. So this is really 9 root 2. Leave the 2 in, the 27 comes out. So this one is really 9 root 2. So I'm going to write it as 9 root 2 just to make it a little simpler. And now I'm going to erase this mess down here so you can see. So you can clean it up. Okay. And now I have still, oops, the cubed root, and this is the cubed root of 3. Now I need 3 factors of 3 in here to get rid of this. That means I have to multiply it by, I get 2 more factors in there, which is why I have to multiply the denominator by the cubed root of 9, which is 3 squared, because this will be now the cubed root of 27 when I multiply. Well, if I multiply the denominator by that, I have to multiply the numerator by that, because cubed root of 9 over cubed root of 9 is 1. Okay, now I'm going to get the cubed root of 27, which is 3, on my denominator, which is exactly what I wanted. Now, this is 3 squared, so I'm adding 2 more 3's in here. So I'm actually going to have 2 times 3 to the 4th. So I have the cubed root of 2 times 3 to the 3rd times 3. That's 3 to the 4th times 2. I know I'm breaking this up into so many steps. I hope this isn't confusing you, but now I'm going to have 2 times 18 is, or 2 times 9 is 18, so I just have 9 times the cubed root of 18. Now, this 3 comes out, and I get 3 times this cubed root of 6 plus 9 times the cubed root of 18 all over 3. This is the one time you can cancel into a sum. When this number goes into all the terms, this one is divisible by 3 and this one is divisible by 3. So now we can cancel this into here, and I just end up with cubed root of 6 plus 2 times the cubed root of 18. And you're done. Now when you have a complete variable expression in here, it's actually pretty easy because you're just taking the index ones out. So I've got the square root, so I'm looking for 2 factors of p cubed. So I get p times p, so 1 p will come out of here, and I'll end up with this one being p times the square root of pr, which I can't do anything about at that point. Then this one, I can take an r out, and I just end up with the square root of pr. Well, square root of pr is common to both of these terms, so I can factor it out. And I'm going to put my sum in front of it as p plus r, because you know the distributive property is not only left distributive, but right distributive. Now again, you're going to just use the distributive property, and in this case, you're just going to multiply through, and what goes inside the things are going to go together. So you've got this, you're going to put them under the same square root sign. 3 times 3 times 2, so I can bring a 3 out, and I've left the 2 in. W times W, I can take the W out. Okay? Plus 6 times 2, I'm going to be able to take a 2 out and leave a 3 in, and W times W cubed is W to the 4th, so I can take W square out, because W squared times W squared is W to the 4th.